Welcome to my statistics class. Let's go ahead and get started. The first thing we're going to do is go through and learn some definitions. What is statistics? The definition of statistics is the science of studying data. So first, what is data? Well, data is numbers given within a context, right? So for example, 12, that's not data. A foot is 12 inches long. That's not really data either, that's a measurement. 12 people arrived at my birthday party early. That may be a lie, but that is a data point, right? So a data is a number with context. If I say, how many people stopped at this gas station per hour, instead of saying 3, you would say 3 people per hour. You have to give the context with it. Context is going to be everything. If you don't understand numbers within a context, then you don't understand what it is that you're doing at all. Individuals, so we'll be referring to things, individuals, subjects, things like that. But individuals, as far as our class is concerned, are objects described by a set of data. So people, animals, things, houses, cars, pets, anything that is in our data set, any object that we are referring to. And then we have variables, which are characteristics of an individual. This is not the same way we've described variables in an algebra class or in a calculus class. For a statistics class, a variable is a characteristic, something about an individual for which we are taking. Obviously, they can be different for different individuals. Variables, as a matter of fact, they probably should be different for different individuals, otherwise they won't vary, hence the name. So things like color, height, length, distance, zip code, brand, weight, anything you can think of where things would vary between two different objects or two different individuals in some data set. Categorical variables. So there's two types of variables, right? Variables are characteristics. We break them up into two different categories. There's categorical variables. You can think of them almost like quality variables, variables that are about some category in which you can put the individual in. So things like color, brand, zip code, country of origin, favorite sport, things like that. Things that you would break things up into different categories for. A quantitative variable is a variable where you take a numerical value of something from an individual, and that numerical value has to be something for which it makes sense to take the average of. And we know average is where you add everything up and find and then divide it by the total number of things in that set. So like things like height, weight, distance, like your grade in a class, for example, like your average test score, things like that. Things like how much time is spent waiting at the bus stop. And there are some things that you could make the argument fit into both quantitative or or categorical, but that's a different conversation for a different time. And the reason we specified for which it would make sense to find an average is because things like zip code, apartment number, or address, these are usually our phone number. These are numerical values. However, it doesn't make sense to find the average zip code for students in a class. That's not something that really makes sense. Meanwhile, it does make sense to ask the question, what is the average height of students in a class? What is the average weight of dogs at this dog kennel? What is the average distance run by soccer players in an average game? All of these things are things where it makes sense to find the average. We'll be dealing with things that we call distributions. So a distribution it tells us what values the variables take and how often it takes them, right? And there's a lot of ways to do this. This will be graphs, tables, things like that. But anytime we're talking about a distribution, we're talking about sort of a snapshot or a visual picture of all of the data at one time. Next, we have inference. Inference is where you draw a conclusion that goes beyond the data that you have right there at hand. There's a right way and a wrong way to make an inference. A lot of people make bad faith inferences, but the best way to do it is just to look at the data that you have there and make sure that that your argument makes sense to say. So for example, if I was going to take a sample of of a bunch of students at Roosevelt. Maybe I found 30 random students at Roosevelt High School, and a lot more than half of them were right-handed. Then my data says that most of my sample is right-handed. Now, if my sample is a good enough sample, then I can say, well, in that case, I can infer that most of Roosevelt or most of the students at Roosevelt are right-handed because my sample is a representative of the students at Roosevelt. So that is an example of an inference. Basically, I take the data that I have from my sample and expand it to the rest of the population. So a population is all of the individuals that fit a given criteria, or all of the individuals for which it makes sense to ask a question about, or all of the individuals in a group, right? So if I'm going to ask a question, what is the average shoe size of people in San Antonio? Then my population is everybody in San Antonio. If I say, what is the average income for people in the United States? Then my population is everybody within the United States. The reason that distinction is important is, like we said before, when we're making an inference, our sample has to be representative of our population. So if my sample is, or I'm sorry, if my population that my question is addressing is everybody in the US, and I only sample people from Texas, then my sample isn't representative of my population. And a sample is a relatively small group of individuals from a population. So if I say, what is the average shoe size of people in San Antonio, and then I only find the shoe size of people at Roosevelt High School, then that's not really necessarily representative of the entire city of San Antonio, because a high school only has a certain age range of people within it. So that is the difference between those two. Next, we have a statistic. This is something that we need to know. So a statistic is a measurement of data collected from a sample. For example, the proportion of right-handed people in my sample is 2/3. That is a statistic. A parameter is a measurement of the population. So an example of that would be 2/3 of San Antonio are right-handed. That would be a parameter because San Antonio is the entire population. I'm making a statement about the entire population. Now, what statistics really is, what we are going to be doing in this class, we're going to be taking data from a sample, using it to draw a conclusion or an inference about a population. So first, we're going to identify the population that we're curious about. We're going to collect data from a sample that is representative of that population. We're going to do some analysis on that sample, and then we're going to use that analysis to draw a conclusion or make an inference about the original population. And that's it. That's what this class is going to be, what we're going to be doing in this class.